You really need to drill 3 holes in an area to really understand the geology of it all. It's like 3 legs of a stool, because then you can start drawing lines between them.
All right, welcome back inside our proactive newsroom. And joining me now is Chris Frostad. He is the CEO of Pure Point Uranium Group. And Chris, it's great to see you again. How are you?
I am very good, Steve. Thanks.
Good, good. So, interesting. You and I were talking recently about drill results and things that happen within the hole itself, and obviously when core comes out of the ground and geologists look at it, all the exciting stuff happens like that. But a lot of people may not understand what that all means and really what happens after the core comes out. So that's what today's discussion is really about. So, tell me a little bit about what a geologist is looking at on these, newly completed drill holes.
Right. Well, we're in the middle of a drill program right now, and we're
Yeah.
actually in the middle of a 2-week hiatus, which gives us a chance to really take a breath and look at some stuff. Because when we go out there and when we're actually drilling, particularly in an area that hasn't been drilled yet, we're relying a lot on geophysics. And you'll typically run a lot of geophysics. And the things to understand about it is that they're not specifically telling you what's in the ground. What they are telling you, and you've all seen those maps. It's a bright red fading into a yellow, into a green, into a blue. But they're not harsh lines. There's not distinct lines, and those colors aren't necessarily telling you what's down there. They're telling you relatively what's down there, in that this rock is denser than that rock, and this rock has a higher gravity than that rock, etc. So, you're looking at it in a way that is going to identify, hopefully, what you think is a target. When we talk about graphite and graphitic conductors, those are things we can get with more specificity, if you will.
Yes.
But the problem with the graphite, again, is you're looking at a line in the basement rock, but you don't know whether it's laying like this or like this or like this, or where it goes, where it starts. So, we spend a lot of time up front determining what the target is, what it is we're trying to hit. And so, going back to your question, when we're putting our first holes in the ground there, we have an idea of what we're hoping to see come out and what we expect to see. So, we're
Yeah.
always, of course, hoping that it's radioactive that comes out of the ground, in our case. But when it does go down there, then that's the first time you're really going to be able to understand a rock type. You're going to be able to understand faulting, which direction that fault goes in. Whether that graphite you were after is at the depth you thought it might be at. So there's a lot of things that we learned besides just radioactivity, that lead us to the, okay, now where do we go from here?
Yeah. It's only one piece of the puzzle, right?
Absolutely. And in fact, you really need to drill 3 holes in an area to really understand the geology of it all. It's like 3 legs of a stool, because then you can start drawing lines between them. Um, so, a lot of people assume that once we've drilled that hole, we immediately know what's down there, and we can figure out what's going on next. To some degree, that's true. If we start to hit things that we expected were going to be down there, and they are in fact down there, and maybe we're seeing radioactivity, because we'll know that right off the bat. We do have to make some calls almost immediately as to where we want that next hole to go. Do we just turn the drill a bit? Do we move it completely? What have you? But the fact is that once you've got that drill core out of the ground, there's so much work that needs to be done to really understand, what it is you're looking at and how it fits into the matrix of that entire area.
Yeah. There's a lot of detailed logging, interpretation of the structure, geochemistry, the lab work as well. There's a lot of things that have to come after that core comes out of the ground.
Exactly, exactly. And what we can do now, because of some of the technologies we're working with, we can take the rock types, we can take the logging that's occurred, we can take the gamma probe that went down the hole and gave us that, and we can start to build 3D images of what it is we're seeing down there. And when you start lining up more than one hole beside each other, and you can join them together in various ways, now you're understanding which way a fault is going, which way a structure is happening, and that's in a rock type. That's really what we're looking for at the end of the day, is that sort of structural complexity that is going to host a deposit.
So how does a geologist, when that it comes out of the ground, and you're saying, "Hey, we were expecting to see this," and then you drill something that maybe not expected, or something that you were expecting but not as much as you were expecting? How do geologists sort of compare those two things?
Well, that, yeah, unfortunately, that happens more than not.
Yeah.
But on the ground, what you are seeing, there's a couple of things. One thing I'll mention is the orientation of that core, and what I mean by that is if I've got a piece of core like my arm here, and it has a structure running through it here that I can visibly see, I'm looking at that core like this. If I turn it this way, all of a sudden my structure is going in a different direction. So we have tools that actually keep that core in the same orientation that it came out of the ground in, so you can start chasing it. But on the ground, they're recording rock type. They're recording structures and faults. They're recording seams. They're recording everything that they see and measuring and marking the distances of all of these things and comparing it to what we had hoped to see down there, what we thought we were going to see. How far deep the target was, how far before we got to the unconformity, that sort of thing. So there's a fair amount that we can get on the fly as it's coming out of the ground, but it's all visual for the most part. It's not until we can actually get a lot of that data into something that allows us to manipulate it and compare it to other things that we can really do a proper job of determining where we want to go to next. And when
Yeah.
when a hole is going to cost you $300,000 to $500,000, you want to take your time sometimes.
Yeah. So is that why those unexpected observations need a bit more time for interpretation before you decide to just, well, maybe we take, 2 feet this way or 3 feet that way, before you decide to make those moves?
Yeah, absolutely. Because sometimes you've nicked it. Sometimes
Yeah.
you've just overshot it or you've just missed it, and you have to, and if you're on the fly doing this on the fly, we didn't hit that target where we thought we would. Maybe we must have overshot it or done something, and you have to make that call as to are we gonna abandon this now? Are we done? Did we kill it, or do we need to move? Do we need to drill another hole just to make sure that it didn't go in the wrong direction?
Yeah. And lastly, how do you take all this information and sort of guide exploration, or really, I guess that's the job, right?
Well, that is the job, and it's a lot of data. When you think about the millions and millions of dollars that are spent on geophysics and surveys and geochemistry and drilling, et cetera, it's all to produce data. It's quite refined data, and there's a lot of software we use and a lot of techniques we use, and mapping and physical mapping. I mean, we will draw these things out so that the people that recognize what they're looking at can stand back, look at it, and really get a picture of what's going on down there. You're really thinking in 3D, which is difficult for a lot of people, especially me.
Absolutely. Hey, Chris, thanks so much. Really good update. Appreciate your time sharing some thoughts about the work that's going on sites. And I know it can be a challenge, but also very rewarding as well. So appreciate your time. Thank you.
Great, thanks, Steve.
All right, there's Chris Frostad, the CEO of PurePoint Uranium Group.